Hello class, today we're going to talk about molar mass. The periodic table indicates the weight of every element in units of AMU or U. It's the same thing. Currently they call it U, traditionally they call it AMU. 1 mole of its element is equal to the weight of the element as shown on the periodic table, only in grams instead of AMU. So the weight you see on the periodic table, as I'm going to show you here, some examples. So for example, the weight of hydrogen, you will see it down here, it says 1.008. The weight of carbon, it's right here, it's 12.011. The unit is AMU. 1 mole of carbon weighs 12.011 grams. So the periodic table shows you the weight of the atom in AMU, and the 1 mole of an element is the weight that the periodic table shows you only in units of grams. So some more examples. If you guys have a periodic table in front of you, you will see that lithium weighs 6.9 AMU and 1 mole of lithium is 6.9 grams. Magnesium, 1 atom of magnesium weighs 24.3 AMU and 1 gram of magnesium is 24.3. 1 mole of magnesium is 24.3 grams. Chlorine weighs 35.5 AMU, but 1 mole of chlorine is 35.5 grams, and so on. In order to calculate the molar mass of a molecule or a molecular or a chemical formula, you just add all the individual molar masses of each element together. So the individual molar masses, you find them directly in the periodic table. But when you have a formula, the molar mass of the whole formula, so the molar mass of water here, for instance, is you have 2 water molecules, therefore you say 2 hydrogen molecules, therefore you say 2 hydrogens equals with 2 times 1. The weight of hydrogen is approximately 1, so it's about 2. And 1 oxygen atom, therefore 1 times 16, since the weight of oxygen is about 16, and the total will be 2 plus 16 equals 18 grams. So 1 mole of water weighs 18 grams. Another example will be the molar mass of zinc nitrate. Zinc nitrate, Zn, NO3 2 is. So I want you guys to be able to recognize how many atoms of each element there is in this formula. So when we say zinc, there is no subscript and no coefficient in front of zinc, so we have 1 zinc. And if you guys go back to the periodic table and you look at the mass of zinc, and we can do that very quickly, the mass of zinc is 65.4 approximately. So 1 zinc equals 65.4 grams. And here, because you have this subscript 2 and a parenthesis, like you guys do in math, if you have 2 in front of a parenthesis, applies to everything inside the parenthesis. So 2 applies to nitrogen, and also 2 multiplies the number of oxygens too. So 2 nitrogens, each nitrogen weighs about 14 grams, and again on the periodic table, nitrogen is here and weighs about 14 grams. So 2 times 14, that's going to give you 28 grams. And then we got oxygen, and oxygen, we have 6 oxygens. Why? Because we have 3 oxygens times 2. You see 3 oxygens times 2, we have 6 times 16 grams, which is the weight of the oxygen, and you can find it on the periodic table, it's approximately 16. 6 times 16 give us 96 grams. Therefore, the total gonna be 65.4 grams plus 28 grams plus 96 grams, 1 mole of zinc nitrate gonna be 189.4 grams. So this is how you calculating the molar mass for individual atoms. That's how you calculating the molar mass for the individual atoms by directly looking at the periodic table. And that's how you calculating the molar mass for molecules or chemical formulas by adding the molar masses of the individual atoms that make up the formula or the molecule. And this is molar mass. I hope you guys find it helpful. Thanks for watching.